If one column mixes text and numbers, your analysis quietly breaks. Sorting looks wrong, totals come out as 0, and filters behave inconsistently. The goal is simple. Get that column into one consistent data type so every tool treats it predictably. In this video, you'll learn a practical workflow you can reuse anytime you see values like 12, 12 kg, NA, $1250, or 0012 living together. We'll start by diagnosing what you actually have, because guessing wastes time. Then we'll separate what's truly numeric from what's just text that looks numeric. After that, we'll clean common patterns like units, currency symbols, stray spaces, and hidden characters. Finally, we'll choose an output format that matches your intent: number for math, text for IDs, or 2 columns when you need both. By the end, you'll have a repeatable checklist that prevents the same mess from coming back next month. Next step. Before you fix anything, decide what correct means for this column. Some columns should be numeric, like price, weight, or quantity. Others should stay text, like product codes, zip codes, invoice numbers, or IDs with leading zeros. This decision changes every step that follows. If you convert an ID to a number, you may lose leading zeros and even change the value. If you keep a true measurement as text, you can't sum it, average it, or chart it properly. A helpful test is to ask, will I ever do math on this field? If yes, aim for a numeric output. If no, keep it as text and focus on standardizing formatting. And sometimes the right answer is 2 columns, one numeric value you can calculate with, plus one text column that preserves the original label or unit. Clarity here prevents you from doing a perfect cleanup that produces the wrong kind of data. Next step. Next, profile the column instead of scanning it row by row. You want to quickly learn what patterns exist. Look for distinct groups: pure numbers, numbers with units, currency values, placeholders like dash or NA, and oddballs like 12-14 or approx 10. Also watch for inconsistent decimal separators like 12.5 versus 12,5. Another common issue is hidden white space, values that look identical but have trailing spaces, non-breaking spaces, or line breaks. If your tool supports it, count how many values are recognized as numbers versus text. If not, create a simple check, attempt a numeric conversion, and flag failures. The point is to stop treating the problem as random. Once you can name the patterns, you can fix them with a small set of rules, and those rules can be documented, reused, and automated later. Next step. A big chunk of mixed types is actually just messy text. So start with safe text normalization that won't change meaning. Trim leading and trailing spaces first. Then collapse repeated internal spaces if your data has things like 12 kg. After that, remove invisible characters that break conversions, like non-breaking spaces copied from web pages. If you ever pasted data from PDFs, this step matters a lot. Also, standardize lettercase for known tokens, so NA, NA, and NA become one consistent placeholder. Finally, decide how you want to represent missing values. A blank is often better than a word like none, because blanks are easier to treat as nulls in calculations. This stage usually fixes more than you expect, and it makes the next steps, parsing and converting, much more reliable. Next step. Now separate numeric meaning from numeric-looking text. A value like 0012 might be an ID, not the number 12. A value like 12 might be a quantity. You can't know without context, so use rules. If the column is supposed to be numeric, create a numeric parse step and capture failures. Anything that fails becomes a review list, not a silent error. If the column is supposed to be text, do the opposite. Keep everything as text, but validate that the text matches the allowed formats, like exactly 8 digits for an account number. When you do parse numbers, treat thousand separators carefully. 1,234 could mean 1,234, or it could mean 1.234 in some locales. Decide one convention and enforce it consistently. The key is to make conversion explicit, not accidental. Next step. Let's handle the most common case, numbers with extra text attached. Think 12 kg, 5 PCS, 1999, or EUR 10. The reliable approach is to extract the numeric portion, not to guess the whole string. First, remove known tokens like currency symbols and unit words. Then extract digits plus one decimal separator and an optional leading minus sign. If your data includes ranges, like 12 to 14, decide a rule. Take the lower bound, take the average, or mark it as ambiguous. Don't pretend it's a single number without choosing. Also watch for parentheses used for negatives, like 1250. That's common in accounting exports. Convert it deliberately to negative 1250. Once extracted, convert to a numeric type and store it in a clean numeric column. Next step. Placeholders and special values deserve their own rule set. You'll see NA, dash, unknown, TBD, 0, and sometimes free. These are not the same thing. NA usually means missing. 0 is a real numeric value. Free might mean zero price, but only in a price context. So map these tokens intentionally. Create a small dictionary, token in, standardized output out. For numeric columns, the best standardized output for missing is a true null, not the number 0. For text columns, you might standardize to a single label like unknown, or you might convert them to blank. Also watch for values like x5 or 100. Those are not plain numbers, but they carry meaning. You can store the numeric part in one column and the operator in another. Next step. Decimals and locale formatting can sabotage an otherwise clean column. The same value might appear as 1,5 and 1.5 depending on where it came from. Thousand separators add another layer like 1234.56 versus 1.234.56. You need one standard. Pick the format your system expects, then normalize everything to it before conversion. A practical method is to detect which separator appears most often, then treat that as the decimal marker. But be careful with small samples. If you can, rely on a known source locale rather than guessing. Also remove thousand separators only after you've identified the decimal separator. Otherwise, you can turn 1.23456 into 1.23456, which is wrong. Once standardized, convert to a numeric type with a fixed number of decimals if appropriate. This step is the difference between clean math and subtle, expensive errors. Next step. Sometimes the best fix is not forcing one column to do two jobs. If your values include both a number and a unit, like 12 kilograms and 500 grams, you'll get better results by splitting into two columns, numeric value and unit. Then you can normalize units, for example, converting grams to kilograms, and keep everything comparable. The same idea applies to currency. Split amount and currency code, then convert using a chosen exchange rate table if that's part of your workflow. Another split pattern is value plus note, like 10 estimated. Put 10 in the numeric column and estimated in a notes column. This approach preserves meaning while still giving you a clean numeric field for calculations. It also makes validation easier because each column has one clear rule. Next step. After cleanup, validate the results like you would validate a calculation. Start by counting how many rows successfully converted to the target type. Then review the failures as a focused exception list. For numeric fields, check summary stats, minimum, maximum, and a quick scan for impossible values, like negative quantities or prices that are too large. For text fields, check length and pattern rules, like must be 10 characters or must start with ABC. Also check duplicates if the field is supposed to be unique. Finally, keep an audit trail. Store the original raw value in a separate column, at least during development, so you can trace any weird outcome back to its source. Validation is what turns a cleanup from looks fine into is reliable. Next step. To keep the problem from returning, make your fix repeatable. Document the rules in plain language. Which tokens mean missing, which units are allowed, which decimal format is accepted, and what happens to ranges. If you can, enforce input constraints at the source, like drop-downs for units or separate fields for amount and currency. When that's not possible, build a lightweight standardization step into your import process, and set up a simple data quality check that runs every time new data arrives, percent numeric, number of exceptions, and top failing patterns. That way, you catch new weird formats early, before they flow into reports and decisions. Mixed data types are rarely a one-time event. Treat the cleanup as a system, not a heroic one-off fix. Next step. Let's wrap this into a quick checklist you can reuse. First, decide the intent: numeric, text, or split. Second, profile patterns and count what converts cleanly. Third, normalize text by trimming spaces and removing invisible characters. Fourth, extract numeric values from strings with units or currency and map placeholders to null or a standard label. Fifth, standardize decimal and thousands separators before conversion. Sixth, validate with an exception list and sanity checks. And keep raw values until you trust the pipeline. If you follow that order, you'll avoid the two classic mistakes: converting too early and hiding failures. If you want more workflows like this, subscribe once for practical data cleaning playbooks. And for a quick pulse check, comment with your situation. Do you usually fix mixed types by converting to numbers or by keeping everything as text? A or B? Subscribe to keep optimizing your workflow and get back more of your time.